Hello student, we are dealing with the unit number 4, classical mechanics, and this is our lecture number 3. Today's date is 18th March 2022. So we have finished the central force and the two body problem and its derivation. Today we will see what is Kepler's first law and its derivation. So you might have studied the Kepler's first law of motion in your schooling. Okay, so I'm going to recall it. Suppose this is a planet and planet is moving in an elliptical orbit. Okay, you know that in ellipse there are two foci, F1 and F2. So what the Kepler first law says, the planet moves around the sun in an elliptical orbit, or sun is one of the foci. Sun may be at F1 or F2. Okay, so this is the animation. The planet is moving around the sun in an elliptical orbit, or sun may be at F2 or maybe at F1 or maybe at F2. So what is the statement? The statement is every planet moves in an elliptical orbit around the sun and the sun is one of the foci. Sun may be at F1 or maybe at F2. सन F1 पे भी रह सकता है, F2 पे भी रह सकता है, और planet elliptical orbit में घूमता है around the sun. Now we will see its derivation. So to start with, we should know the differential equation of the orbit. So this is the differential equation of the orbit: d2u by d theta square plus u is equal to minus m l square u square f of 1 of u 1 by u. This is the first equation, and we know that according to the property of the central force, okay, according to the inverse square law, the central force is given by Fr is equal to minus k upon r square, means Fr is inversely related to the square of r. Okay, and this is the equation. Suppose this is the equation number 2, and you know that put r is equal to 1 by u. Put in this equation r is equal to 1 by u. So we will get the equation 2 become f1 by u is equal to minus k upon 1 by u square. So it will be minus k u square. Okay, so f1 by u is equal to minus k u square. Suppose this is the equation number 3, and put the value of this f1 by u in equation number 1. What is the equation number 1? This is the equation number 1, and we have found out the value of f1 by u from this inverse square law. So we will get f1 by u is minus k u square. So putting the value of f1 by u in equation number 1, so the equation number 1 becomes d2u by d theta square plus u minus m upon l square u square. f1 by u is the minus k u square, that is the from equation number 3. So after solving these, u square got cancelled, u square get cancelled, and we will get d2u by d theta square plus u is equal to minus plus mk upon l square. Okay, and if I take this mk upon l square to left hand side, then I will get the differential equation d2u by d theta square plus u minus mk by l square is equal to 0. So this is the equation number 4. Okay, so this is the equation number 4. We have started the derivation with the differential equation of orbit, and we have modified the equation by putting the value of f1 by u. Then we will get this equation d2u by d theta square plus u minus mk upon l square is equal to 0. This is the equation number 1. Now suppose u is minus mk by l square is equal to x. This is the equation number 5. We are supposing, because we have to solve this differential equation, so we are considering u minus mk upon l square is equal to x. Okay, suppose u minus mk upon l square is equal to x. This is the equation number 5, and we are differentiating this equation with respect to theta. So differentiate is because we want to solve this equation d2u by d theta square plus u minus mk upon l square is equal to 0. We have to solve this differential. For solving that, we have to consider, or we are supposing u minus mk upon l square is equal to x. Okay, so u minus mk upon l square is equal to x, and differentiating with respect to theta. So what is the differentiation of u with respect to theta? Du by d theta. Mk l square is constant, and it will become dx by d theta. So du by d theta is equal to dx by d theta. Mk upon L square is constant, so differentiation of this term is 0. So we will get du by d theta is equal to dx by d theta. Okay, again if we again differentiate these with respect to theta, then we will get the differentiation of higher order, that will be d2u by d theta square is equal to d2x by d theta square. We will get d2u by d theta square is equal to d2x by d theta square. This is the equation number 1. And from equation number 5, u minus mk upon L square is x, and d2u by d theta square is equal to d2x upon d theta square. So from equation number 5 and 6, the value of equation number 5 and equation number 6 we will put in this differential equation 4. Okay, because we know u minus m upon L square is x, and d2u by d theta square is d2x by d theta. So putting the value of u minus mk L square and d2u by d theta square in equation number 4, putting the values of equation 5 and 6 in equation number 4, so we will get d2x upon d theta square plus x is equal to 0. Suppose this is equation number 7, and this is the differential, second order differential equation. Okay, this is the standard format, second order differential equation, d2x d by d theta square plus x is equal to 0. So we know the solution. So what is the solution of this equation number 7? This is the second order differential equation. The solution of equation number 7 is given by x is equal to a cos theta minus theta dash, and theta dash is constant and a is constant. So the solution of this second order differential equation, according to the formula for differential equation, the solution will be x is equal to a cos theta minus theta dash, and theta dash and a are constant. Theta dash, where a and theta dash are constant. So now we will get x is equal to a cos, because the solution, the standard solution of this standard second order differential equation is x is equal to a cos theta minus theta dash, and a and theta dash are constant. But you know the value of x from equation number 5. Okay, value of x is u minus mk upon L square. So in place of x we will put u minus mk upon L square. From equation number 5 we will have the value of x, u minus mk L square is equal to a cos theta minus theta dash. And what about the next step? Next step, you have to bring mk L square to that side, so we will get u is equal to mk. We will bring that mk upon L square to that side, so we will get u is equal to mk upon L square plus a cos theta minus theta dash. And then we know that u is equal to 1 by r. U is equal to 1 by r, so we will get 1 by r is equal to mk upon L square plus a cos theta minus theta dash. So this is the equation number 9, and we know that u is equal to 1 by r. Now what we will do, okay, we have got 1 by r is equal to mk upon L square plus a cos theta minus theta dash. This is the equation number 9. Now we will multiply both sides by L square upon mk. We will multiply both sides by L square upon mk, because in this position we want 1, so we are multiplying both sides by L square by mk. So after multiplying L square by mk into 1 by r is equal to L square by mk into mk upon L square plus L square by mk into a cos theta minus theta dash. So we are multiplying L square by mk on both sides. Okay, now what we will get, this one, this term L square by mk and mk by L square cancelled out. Okay, now we will remain with L square upon mkr is plus L square a upon mk cos theta minus theta dash. So we'll get L square by mkr is equal to 1 plus L square a cos theta minus theta dash upon mk. So this is the equation number 10. Suppose this is the equation number 10. Then what we'll do next? Comparing above equation, the general equation of conic section. Now we will compare this equation with general equation of conic section. Equation number 10 will compare the general equation. So what is general equation of conic section? So this is the general equation of the conic section. L by R is equal to 1 plus E cos theta by theta minus theta dash. So if we compare this equation, here L by R, here 1 by R, and extra term is here 1 by R, L by R, here L by R. So here extra term is L square upon mk. This is 1 by R. R is already there and R is here. So in place of L, here is L square by mk, the coefficient of 1 by R. The coefficient of 1 by R is L square by mk. Here coefficient of 1 by R is L plus E cos theta minus theta. So cos theta minus theta dash is here. Cos theta minus theta dash is here. So what is the coefficient of cos theta minus theta dash? L square A upon mk. So in place of E, here is L square A upon mk. L square A upon mk. Okay, so by comparing above equations, so in place of L, here is L square by mk. In place of E, here is L square A upon mk. So by comparing, we will get L is equal to L square by mk and E is equal to L square A by mk. So this is the equation number 1. By comparing the general equation of conic section with equation, by comparing the equation number 10 with the general equation of conic section, so we will get L is equal to L square by mk and E is equal to L square A by mk. So this is the equation number 11. Okay, so what we'll do next, now differentiate equation number 10 with respect to t. Okay, now differentiate equation number 9 with respect to t. What is equation number 9? This is the equation number 9. We have to differentiate this equation number 9 with respect to t. So what is the differentiation? So 1 by R. So the differentiation of 1 by R is minus 1 by R square dr by dt. Okay, and case L square is constant, so differentiation will be 0. And what is the differentiation of A cos theta minus theta dash? A is constant, cos theta. What is the differentiation of cos? Minus sine theta minus theta dash. And this theta dash is constant, but theta with respect to theta or with respect to time, the differentiation of theta is d theta by dt. So after getting the value of L and E, we will have to differentiate equation number 9 with respect to t. Okay, again I am telling what is the differentiation of equation number 9. Differentiate 1 by R with respect to t, so minus 1 by R square dr by dt. Okay, is equal to mk. L square is constant, so differentiation with respect to t would be 0 plus, okay, 0 plus A is constant, so differentiation of cos with respect to time t is minus sine theta minus theta dash, and differentiation of theta with respect to time is d theta by dt. So we will get the differentiation of equation number 9 minus 1 by R square dr by dt is equal to 0. A cos ka differentiation minus sine theta minus theta dash into d theta by dt. Now you know that dr by dt in classical mechanics I can write as r dot, d theta by dt I can write as theta dot. Okay, minus minus cancel out, so we will get 1 by R square R dot is equal to A sine theta minus theta prime or theta dash into theta dot. So we will get the differentiation after we will get the differentiation or differentiating equation number 9 with respect to time t. Now I will bring this R square to right hand side, so I will get R dot is equal to AR square sine theta minus theta dash into theta dot. Okay, since now suppose L, you know that the angular momentum is I into omega, moment of inertia into angular velocity, but moment of inertia you know that mr square, and angular velocity is rate of change of angular displacement, that is theta dot. Okay, so you know that L is equal to I omega is equal to mr square. I is moment of inertia is mr square, angular velocity is d theta by dt, so it is theta dot. So from this equation I can find out the theta dot. Mr square I will bring to that side, so theta dot is nothing but L by mr square. So in place of theta dot I can write as L by mr square. Okay, so in place of theta dot I can write as L by mr square. Okay, I will get then R dot is equal to AR square sine theta minus theta dash into L by mr square. So R square got cancelled, or R square get cancelled. So I will get R dot is equal to AL by m sine theta minus theta dash. r dot is equal to al by m sine theta minus theta dash. This is the equation number 12. So this is the equation number 12. Now we know that what is the total energy of the particle moving under central force. Total energy means kinetic energy plus potential energy. So total energy of particle moving central force field, we know that E is equal to, this is kinetic energy and this is potential energy. So E is equal to half mv square plus v by r, vr plus L square upon 2m r square. So this is kinetic energy plus potential energy. So we'll get half mv square plus vr plus L square upon 2m r square. Okay. Now v, velocity, we know that velocity is rate of change of position vector. So in place of v I can write as r dot, so it will become half m r dot square. And potential energy for central force field, potential energy of central force field for a particle moving in central force is, we know that minus k by r. So in place of v r we can write as k by r plus L square twice mr square. Okay, but we know that the value of r dot, so what is the value of r dot? Al by m sine theta minus theta dash from equation number 12. So vr being minus k by r. So putting the value of r dot and 1 by r from equation 9 and 12 in above equation. This is the equation number 12. Okay, so we know the value of 1 by r. What is the value of 1 by r? From equation this one from equation 9. Okay, from equation 9 the value of 1 by r, this is the value of 1 by r, mk upon L square plus a cos theta minus theta dash from equation 9, the value of 1 by r. And what is the value of r dot? The value of r dot is al by m sine theta minus theta dash from equation number 12. So we will put the value of r dot and 1 by r in this equation number 13 from equation number 12 and 9. Here is r dot, so we'll put the value, this value, and here is 1 by r, we will put the value from equation number 9. So after putting the value we'll get E is equal to half m. Okay, this is the value of r dot al upon m sine theta minus theta dash whole square minus k. This is the value of 1 by r from equation number 9, mk upon L square plus a cos theta minus theta dash plus L square by twice m. This is the value of 1 by r again, mk L square plus, again I am showing that equation, this value. Okay, r dot square, the value, this is the value from equation number 12. We have to put the value of r dot minus k by r means k into 1 by r. This is 1 by r, the value of 1 by r is from equation number 9. L square by twice m, this is r square, again 1 by r square. Okay, so we have to put the value of r dot here. Okay, and 1 by r in second term and 1 by r square in third term. So after putting these values we'll get half m al by m sine theta minus theta dash whole square minus k mk upon L square plus a cos theta minus theta dash plus L square by twice m mk L square plus, this is the value of 1 by r, here 1 by r square, this is the value of 1 by r, and this is the value of r dot. So after calculating or after solving this bracket, okay, we will get half m, their square of whole term a square L square m square sine square theta minus theta dash minus k mk upon L square plus a cos theta minus theta dash. Okay, as it is this term, and this is whole square, so a plus b whole square, a square m square k square upon L to the L square of L square L to the power 4 plus twice ab. This is a plus b whole square, a square plus 2 into ab plus b square. So 2 mk into L square into a, so a mk L square cos theta minus theta dash plus b square a square cos square theta minus theta dash. Okay, then we'll solve this bracket again. So after solving, here mm cancelled out. Okay, 1m will remain. Okay, then it will become a square L square twice m sine square theta minus theta dash minus mk square L square plus ak cos theta minus theta dash. So after solving the bracket, okay, we will multiply L square by twice m to whole terms of this bracket. So after multiplying we will get L square by twice m into m square k square into L to the power 4 plus L square by 2. We are multiplying L square by 2 for whole term because this term is common to that bracket. Okay, after multiplying we'll get first term as it is, a square L square twice m sine square theta minus theta dash. Second term I will open the bracket, minus m k square upon L square plus minus minus a k cos theta minus theta dash, plus here look at here L square and L to the power 4, here L square will remain and cancel out, so only mk in the numerator mk square, okay, upon 2L square, plus here in second term L square get cancelled out, get cancelled, 2 get cancelled, can get cancelled, and will remain with k cos theta minus theta dash, a k cos theta minus theta dash, plus in third term L square a square upon twice m cos square theta minus theta dash. So we will get this from these terms, okay, after cancelling some terms. Okay, so in the look at this equation, here is minus ak cos theta minus theta dash and here is ak cos theta minus theta dash. So minus and plus, these two terms have cancelled out. Okay, now here look at these two terms mk, these two terms, a square L square twice m sine square theta minus theta dash, a square L square twice m cos square theta minus theta dash. So here a square L square twice m, a square L square twice m is common term, we will take common, and in bracket the term will remain sine square theta minus theta dash plus cos square theta minus theta dash, and here is also mk square by L square, mk square by L square is common, so mk square by L square will take outside to 1 minus 1 by 2. So these two terms, okay, these two terms. So after solving these, we'll get a square L square twice m sine square theta minus theta dash cos square, here minus mk square L square common, 1 minus 1 by 2. Okay, but we know that according to the identity, sine square theta plus cos square theta is 1, so sine square theta minus theta dash plus cos square theta minus theta dash is 1. We'll get then is equal to a square L square by twice m minus mk 1 minus 1 by 2, 1 by 2, so 1 by 2. So we'll get here mk square L square into 1 by 2. So we will remain with is equal to a square L square upon twice m minus mk square upon twice L square. Okay, we'll bring this term into the left hand side, to E is equal to mk square plus upon 2L square is equal to a square L square by twice m. So here okay, we are rearranging the terms, a square L square twice m is equal to E plus mk square upon twice L square. Okay, so after rearranging them, we are taking common the term mk square, okay, mk square upon twice L. Okay, after that we are taking common 2m by L square. Again look at this slide, here a square L square upon twice m is equal to E plus mk square twice L square. So we are bringing this L square by twice m because we have to calculate a square, so we are bringing this L square by twice m to that side. Okay, so we'll get a square is equal to twice m by L square E plus mk square upon twice L square. So again I'm telling that here I want to calculate a square, so L square by twice m I'm shifting to that side, so it will be a square is equal to twice m by L square in the bracket E plus mk square upon twice L square. So a square is equal to twice m L square E plus mk square upon twice L square. Okay, in this bracket we'll take common this term mk square by twice L square, so I'm taking the term common mk square by twice L square from this bracket, so we'll get a square is equal to twice m by L square into mk square by twice L square common, so E upon mk square by twice L square plus 1. Okay, after solving this bracket, twice L square go to the numerator, so we'll get a square is equal to m square k square upon L square twice in the bracket twice L square E upon mk square plus 1. We'll get this term. Okay, so in next step, taking square root on both sides. So we will take the square root because we have to find out the value of a, so we are going to take the square root. So after taking square root, we will get m is equal to mk by l square in under root 1 plus twice l square e upon mk square. Okay, we'll get the value of a. Okay, now after getting the value of a, we'll put this value into the equation of eccentricity. But we know that eccentricity from equation number 11, L square A upon mk. So in the equation of eccentricity, we will put the value of A, this one, mk upon L square under root 1 plus 2 L square E upon mk square. So after putting the value of A from above equation into this eccentricity's equation, okay, in the equation of eccentricity, we'll put the value of A. So what is the value of A? This one. So after putting that, E is equal to L square upon mk by L square. So L square mk got cancelled, these two terms got cancelled, so we will remain with E is equal to 1 plus twice L square E under root 1 plus twice L square E upon mk square. So this is the equation of eccentricity. If suppose squaring on both sides, if we square this term on both sides, after squaring, E square is equal to 1 plus this square root got out, okay, because of the squaring on both sides. E square is equal to 1 plus twice L square into E by mk square. So I will bring this one to that side, to E square minus 1 twice L square E by mk square. Okay, and I calculate E from here, and twice L square mk square I will bring to left hand side. So we will get E is equal to mk square by twice L square E square minus 1 is equal to E, and E is equal to mk square by twice L square in the bracket E square minus 1. This is the equation number 14. Okay, the value of E, now we will get this equation number 14. E is equal to mk square upon twice L square E square minus 1. Now just look at this equation. Just look at this equation. M, K and L is constant, E. So the value of E decide the nature of orbit, E square minus 1. If suppose E is 0, so equation number 4 becomes, if E is 0, the equation number 4 becomes E is equal to minus mk square upon 3L square. So the orbit is circular. This is the equation of circle. If E is 0, if suppose the value of eccentricity is 0, so 0 minus 1 minus, so the equation number 14 becomes E is equal to minus mk square upon 3L square. So the orbit is circular. If suppose E is 1, if E is 1, then E is 1 square minus 1 square 1 minus 1 0. So E, the value of energy is 0. In equation number 14, the value of energy is 0. It means the orbital is parabolic. The orbit is parabolic. If E is less than 1, if E is less than 1 means E is negative. If E is negative, okay, if eccentricity is negative, if E is the value of eccentricity is negative, then E is also negative, because negative minus negative is negative. Okay, if E is less than 1, it means if E is less than 1, so if E is less than 1 means the value, the less than 1 means the less value minus more value, so E will become negative. So E is also less than 0. If E is less than 1, then total energy is less than 0, and then orbit is elliptical. And second, if E is greater than 1, if E is greater than 1, if E is more than 1, E is positive, E is greater than 0, is positive. If E is more than 1, if suppose E is more than 1, if suppose E is 2 square minus, so this will positive value, E will be the positive, E is greater than 0, and orbit is hyperbolic. Orbit is, so this is the significance of eccentricity values. So we have seen the statement of Kepler's first law, and we will derive the equation for Kepler's first law, and we got the value of energy. Okay, energy and eccentricity will decide the shape of orbit. Okay, if E is greater than 1, then orbit is hyperbolic. If E is less than 1, the orbit is elliptical. If E is equal to 1, it means that orbit is parabolic, and if E is 0 then orbit is circular. So the value of E decide. So this is the statement, this is the proof for Kepler's first law of motion. So today we have seen what is Kepler's first law, and we have derived, and we have come up with the equation which decide the nature of the orbit. So that's all for today. Okay, now in next lecture we will see what is Kepler's second law and its proof. So bye bye.